Now, sometimes we need to go for some empirical relation of the Cotter joint. Okay, so sometimes it happens that there are n number of components connected to the Cotter joint, like IC engine or another prime mover is connected. Okay, so at that time, Cotter joint design we have to finish as early as possible. So at that time, we can actually design Cotter joint with some empirical relation. Okay, so with empirical relation we are having shaft diameter small d, and with respect to small d we can calculate all remaining diameters, that is d1, d2, d3, d4, a, c, b, t, t1, etc. Clearance is from 1.5 to 3 and taper is from 1 is to 32. For better design we can calculate all this dimension, and we can compare this dimension with the dimension calculated by the design formula, and we can select larger dimension. So always we have to keep it in mind that for stresses, if we are calculating stresses by two ways, okay, then stress value should be least amongst two and value of the dimension should be more amongst two. So d1 if we are calculating by this formula, and d1 we are calculating by formula of the uh, formula of your stress, and if I am getting d value greater in the stress calculation, then I have to select the d1. So what I mean to say, we have to select dimension on the higher side if two dimensions are calculated, and if two stresses are calculated we have to select the least amount of stress. Stress should be on least side and dimension should be on highest side. This is what I want to say. Then design procedure of Cotter joint. How we are, these are the formulas how the failure takes place. But if I want to join or if I want to design the Cotter joint, then what should be the process, that we'll see now. So first calculate the diameter of each rod by equation. So what equation is there? D is equal to 4p upon pi sigma t. See, we have seen all these formulas. Okay. Next, what will be the next thing? Next is calculate the thickness of Cotter by empirical relation. Okay, so thickness of Cotter by empirical relation T is equal to 0.31 times D. Next, calculate the diameter of D2 of the spigot on the basis of tensile stress. Okay, so what is the value of D2? So P is equal to pi by 4 D2 square minus D2 into T into sigma D. Now you can observe here, if I want to calculate D2, then D2 square minus D2, this becomes a quadratic equation. So in this case, D2 will have two values. So higher value we have to select. If one value is positive, another value is negative, then positive value of D2 we need to select. If one is complex, one is real, then real values we need to select. Okay, because it is a quadratic equation, it will give the two values of D2. Okay. Next, fourth is, so what will be the fourth? Fourth is calculate the outside diameter D1 of the socket on the basis of tensile stress in the socket. So P is equal to pi by 4 d1 square minus d2 square minus d1 minus d2 into t into sigma t will be the value of your value of the d. So in this case already we found out d2. Again I am getting value of d1 as a quadratic equation. Again the same procedure, higher value of d1 we need to select if both are positive. If both if one of them is positive and one of them is negative, then positive value we need to select. If one of them is real, another one is a complex, then real positive value we need to select. Next, the diameter of the spigot collar D3. The diameter of the socket collar D4 are calculated by using following empirical relation. So D3 is equal to 1.5D and D4 is equal to 2.4D. Next, next is the dimensions A and C are calculated by the following empirical relation. A is equal to C is equal to 0.75D. Next, calculate the width B of the quarter by shear consideration using equation and bending consideration using equation, and select the width whichever is maximum between these two values. So for B we are having two things, that means quarter width we are having two consideration, one is shear failure consideration, another one is the bending failure consideration. What are the formulas of these formulas? B is equal to P upon 2T to tau into t, or b is equal to 3p upon t sigma d2 by 4 plus d4 minus d2 by 6. These formulas already we have seen. These are just simplified formulas. Next, what is the next value? Next is check the crushing and shear stresses in the spigot. Okay, so sigma c is equal to p upon t d2, and tau is equal to p upon 2a d2. These values sigma c and tau are for checking purpose. That means sigma c and tau has to be calculated for material, and this value p upon tau d2 and p upon 2a d2 must be less than sigma c and tau. Next is calculation of check the crushing stress and shear stresses of the socket. Okay, so sigma c is equal to p upon d4 minus d2 into t, and tau is equal to p upon 2 d4 minus d2 into c. So in this case also, the term towards right side p upon t d2, whatever sigma c we are getting for the material should be less. Similarly for shear stress in socket end, whatever value we are calculating p upon d4 minus d2 into t should be less than crushing value of the material. So while seeing the problem, we will come to know how to calculate these, or how to follow the design procedure. Okay, so this is all about the design of Cotter joint. So next we'll see the numerical on Cotter joint. After seeing a numerical on Cotter joint, we will go for the next type of joint, that is knuckle joint. Thank you.